I'm going to discuss about variation of parameters, but before that, let us take a look at the homogeneous equation of second order first. The standard form of second order is given by ay double prime plus by prime plus cy equals to fx, and fx can be 0 or non-zero. So let us consider if we have homogeneous equation fx equals to 0. Okay, so that we need to transform this equation in the form of characteristic equation first. Okay, by letting y equals to emx be a solution to this one, and then we have am squared plus bm plus c equals to 0. So that we need to find the roots. If b squared minus 4ac greater than 0, here we will have two different roots here, and then this is the solution of your DE. If you have b squared minus 4ac equals to 0, here you have two equal roots, so this is your solution. If you have b squared minus 4ac less than 0, so that you have two complex roots, it is good if you can apply the formula to find the roots instead of using your calculator, and then this is your solution. And note that the solution of your homogeneous equation are these three forms, and this form is actually YH equals to AY1 plus BY2. Where is your Y1? In here you have EM1X. Here is your Y2, EM2X. EMX is your Y1, your Y2 is XEMX. Your Y1 here is E exponent alpha X cos beta X. Your Y2 here is exponent alpha X sin beta X. Okay, so that is how we find our Y1 and Y2. Okay, for non-homogeneous equation, we discussed two methods to solve the equation. For constant coefficient, so ay double prime plus by prime plus cy equals to fx, and your fx is non-zero, so that is non-homogeneous equation. If you just have constant coefficient, we can solve this equation by using UCM or VPM. Recall UCM very quickly. So we have the solution is y equals to YH, what we have found just now from the homogeneous solution, plus YP. And this YP is depending on what is the type of your fx. Okay, it can be case 1, case 2, case 3, or case 4. Case 5 can be sampai case 5. Case 5. So case 1, the fundamental is the case 1. You have fx is a polynomial function of x to the power of n, where n is equals or greater than 0. For example, if you have fx equals to 2x squared minus 7, so the highest degree here is x squared, so that your yp is x to the r cx squared. So this x squared will follow the highest degree of your function. So if you have fx equals to 2x minus 7, so the highest degree is 1, so you just have x to the r cx plus d. So you begin your yp with the highest degree and followed until you have the degree to the power of 0. Okay. You can have fx equals to exponential function, but it is just in the form of CEKX only here. CEKX only. So your YP is CEKX. K will follow whatever K in your questions. Okay, but C remain as C. Your case 3, your fx can be trigonometric function, but strictly in the form of cosine and sine only. C cos x, D sin kx, C cos kx plus or minus D sin kx. Your initial guess must be the combination of sine and cosine here. For whatever you have sine, cosine, or combination of sine and cosine, but your YP must be combination of sine and cosine. So that is homogeneous equation and UCM. So today we are going to discuss about VPM. Okay, so for VPM, still you must have a constant coefficient of second order with your fx is non-zero. YH plus YP is your solution, but YH is a homogeneous equation, AY1 plus BY2 just now. But the new thing here is YP. What is YP in VPM? So YP in VPM is given by UY1 plus VY2. Okay, what is U and what is V? U and V comes from the formula U negative integrate your Y2 fx over AW, integrate with respect to x. Your V integrate Y1 fx over AW dx. Note that your y1 and y2 here, y1 and y2 comes from your homogeneous solution here. You must choose your y1 and y2. Fx comes from your question here. From your question. Okay. A is also comes from your question, which is this one. Okay. And your W is given by the Wronskian. W is you setting up your y1. Below y1 is the first derivative of y1. Next to y1 is your y2. Below your y2 is the first derivative of your y2. So you just cross multiply. Then you get your Wronskian. Okay. So for example, if we have the question like this. Okay. Solve the following differential equation by using VPM, variation of parameters method. Y double prime plus 4y prime plus 3y equals to e negative 2x. Actually, this question can be solved by using UCM, case 2. But in this question, it just need us to use VPM. So it's okay because VPM can solve for any second order non-homogeneous with constant coefficient, any questions. But for UCM, it is just limited for the first 3 cases. Polynomial of degree n where n is equals or greater than 0 only. Your exponential function just in the form of CEKX cannot be CEKX square, cannot. Okay, and the third case is fx equals to trigonometric function just in sine and cosine. It cannot be secant square. It cannot be equals to tangent square x. Cannot. So UCM is just limited for the first 3 cases, but VPM is more powerful than the UCM. Okay, so take a look on how to solve for this one. Find YH first, and then you need to find your YP, which is UY1 plus VY2. Find YH first. So we have Y double prime plus 4Y prime plus 3Y equals to 0 by equating your Fx equals to 0 so that we have homogeneous solution. Transform in the form of characteristic equation. Find the roots, and you get 2 different roots. When you have 2 different roots, just now, the solution is where? This one. 2 different roots, okay? AEM1x plus BEM2x, so that we write the correct form of your solution. Y equals to AE negative x plus BE negative 3x. So now, we are going to solve for what? Solve for U and V. Okay. So what is U and what is V? Before we get U and V, if we look at the formula just now, you have U equals to negative Y2 Fx over AW integrate with respect to X. But you need to find what is your Y2 and what is your W first. Okay, find W. Find W. So first is Y1. Y1 is exponent negative X. Next to your Y1 is E negative 3x. Below this one is negative E negative x. Differentiate again, so you have this one. So you cross multiply here, so you have negative 3 E negative 3x. This one minus minus, so you have plus E negative. Sorry, this one is E negative 4. Okay, negative 1, negative 3, so you have negative 4. Negative 4x. So that you have negative 2e negative 4x as your Wronskian. Okay, so substitute here. So you have negative. What is y2 just now? We set e negative 3x. Our fx just now is fx. Look at the question back. E negative 2x. So we have e negative 2x over a just now is 1. Your Wronskian is negative 2e negative 4x dx. Okay, we try to simplify. Just simplify. Negative negative is positive. 1 over 2. So you have 1 over 2 outside. I just take out half. Okay, outside from your integrand. So simplify. E negative 3. E negative 2 is e negative 5. Minus minus 4 is plus 4. So you have e x dx. e negative 5 plus 4. So you have e negative. So we have to integrate this one. So we have negative half e negative x. No need to plus any constant. Just remain the solution as this one because we already have constant in YH. 2 constants enough. Okay, v y1 fx over a w dx. Y1 just now is e negative x. Your fx is, what is our fx just now? E negative 2x. Okay. Over a is 1. Wronskian is negative 2 e negative 4x dx. Okay. Equals to e negative. So this one we try to simplify. We have negative half. Okay. E negative is e negative 3. Negative 3. Negative. So plus. So you have ex. Dx. E negative 3 plus 4 is ex lah. So we have negative half ex. Alright. So we already got our uv and YH, so that we can find our final solution, which is y equals to YH plus UY1 plus VY2. YH just now is AE negative X plus BE negative 3X plus U just now is negative, okay? So we have minus half E negative X, Y1 just now is E negative X, okay? Plus VY2. So plus V is what? Half EX. Your Y2 just now is E negative 3X. So you just simplify and then you get the solution. Easy, right? So that is variation of parameters method.